It is time to explain to you how the for loop really works that we have used already without paying much attention to the details. There's only one little thing that you actually haven't seen explained yet, which is the I++ part inside the for loop. The rest you're already familiar with, and I'll just explain to you how all the pieces fit together. Let's look at a for loop that repeats 3 times. In order to do so, we had to declare a variable, and we often call that I, and then we type for I equals 0, I less than 3, I++, and then something inside that gets executed and repeated within the for loop. For example, we might simply print out the value of I here. So printf I has the value, and then we put in a %d, and for that %d, we simply put in the actual value of I. Now, the one thing here that looks unfamiliar is this I++. It turns out I++ is simply short for I equals I plus 1. And that you have seen before. I equals I plus 1 is an update condition that increases the value of I plus 1. So instead of I plus plus, you might also write I equals I plus 1. And I'll do that for now so that you can see it does the exact same thing. For now, let's simply run this program. But instead of running it all at once with a run button, we're going to this time execute it with a step-by-step button so that we can see one step at a time what's really happening. So I hit that button, and at first we get to the place where the variable I is declared. You can see it showing up in the variable editor. I is now there. And next, I is initialized. The condition I equals 0 is executed. And I gets the value 0. It already had the value 0, but that's a Codecast specific thing. In other compilers, that wouldn't be happening. Next, we check whether I is less than 3. I is indeed less than 3, and so now the loop is entered. Because I is 0, it's less than 3, the loop is entered. It's almost like an if statement. If I is less than 3, then enter the loop. That's what just happened. So now this print statement is going to get executed, and we print out I has the value 0. Next, I equals I plus 1 is executed, so the value of I is now updated. I used to have the value 0, and when I execute this statement, I then has the value 1 afterwards. Now that I has been updated, the loop termination condition is checked again. Is I still less than 3? Well, I now has the value 1. 1 is still less than 3, and again it acts like an if statement. If I is less than 3, then go back into the loop. And that's what's happening. We're going back into the loop and printing out that I now has the value 1. Again, now comes the update condition. I is again increased by 1, so that next I has the value 2. Now that I has the value 2, we again check whether the termination condition is met. I is still less than 3, and so we're re-entering the loop yet again in order to print out that I now has the value 2. Next, I is increased again. Now I is going to have the value 3. When we now check whether I is less than 3, that's a strictly less than 3, that is no longer the case because 3 is not strictly less than 3. 3 is equal to 3, but not less than 3. And so this condition is no longer met. So my if statement sort of returns the value false, and that means I no longer enter the loop, I exit the loop, and I get placed outside of the loop at the return statement, and my program finishes. So how did all this work? So in a loop, we have an initialization condition that gets executed first thing. I gets set to a certain value. Next, the termination condition is checked. Am I even allowed to go into the loop? If so, then I enter the loop and do whatever I'm told to be doing. And when I'm done doing what I'm told to be doing, then I is updated. The update condition is executed. After the update condition has been executed, the termination condition is checked again. If it's still true, we're going back into the loop. I is updated. Termination condition is checked until the termination condition is no longer true, in which case I exit the loop. And you can now see that we could actually make a lot of changes here. We don't have to initialize at 0, check whether I is less than just one number, and update just in this one way by counting by ones, I can do something else. So let's check something different. Let's start at 2. Let's initialize I at 2. And instead of checking whether I is less than 3, why don't we check whether I is less than or equal to 5? And instead of adding just 1 to I, let's update it by increasing its value by 2. Let's find out what happens. Let's compile this again and again execute step by step so that we can understand what's happening. I is declared, and we get to the initialization condition. The initialization this time is I is equal to 2. So watch what happens in the variable editor when I execute this step. I now has the value 2. Now we check the termination condition. Is 2 less than or equal to 5? Yes, it is. And since it is, we enter the loop. And this printf statement will then print out that I has the value 2. And that's what just showed up in the terminal window. Next, I is updated. Instead of adding 1, I'm adding a 2 to the I. So my new value for I is going to be 4. The termination condition is checked again. Is 4 less than or equal to 5? Yes, it is. So we re-enter the loop and print out that I now has the value 4. Next, I is updated again. I again add 2 to my value of I. So 4 becomes a 6. 6 is no longer less than or equal to 5. And so I exit the loop and I find myself at the end of the program. So you can do all kinds of things, We can even, instead of increasing I, decrease I. So why don't we start now with I equals 3 as our initialization condition? And let's suppose we want to decrease I by 1 in each step. So we start at 3, and then we're going to go to 2, and then we're going to go to 1, and so forth. What termination condition should I choose? If I keep the current termination condition, it seems like I'll never get there. Because if I start at 3, go to 2, to 1, 0, minus 1, minus 2, minus 3, I just keep decreasing I, and my termination condition, my loop condition remains true for all times. And so it seems like I will have produced an infinite loop. That's not really good. Let's not do that. So what termination condition would be better? Well, for example, we can check whether I is greater than 0. If we check whether I is greater than 0, then I will enter the loop a few times, but as soon as I hits the value 0, I'm going to exit the loop. You always want to pay attention that you construct your loops so that they exit at some point, so you don't construct infinite loops. Let's quickly compile this and again run this step by step. I is initialized at 3. We're checking whether 3 is greater than 0. Indeed it is, and so we're printing out that I has the value 3. Next, I is decreased by 1. I now has the value 2. We're checking whether 2 is greater than 0. Indeed it is, so we're printing out that value. We're decreasing I by 1 again. I then has the value 1. 1 is still greater than 0, so we're printing out I has the value 1. We're decreasing I one more time. I now has the value 0. 0 is not strictly greater than 0, and so the termination condition is no longer satisfied, and so we're exiting the loop, and the program ends. Now, it's time for you to start playing. Go ahead and play with different initializations, updates, and termination conditions to really understand how these loops work. And don't be too afraid to accidentally program an infinite loop. Let me show you what happens. Very easily, if I change this again to I equals I plus 1, I have created an infinite loop. Because I initialize I with 3, I check whether it's positive, and I keep increasing I. So I goes from 3, 4, 5, 6, 7, 8, 9, 10. My condition is always true, and so I always remain in the loop. Let's compile this and run. Look what happens. It just keeps counting and counting and never ends. If you found yourself in that kind of a case, don't worry. Just hit the stop button. As soon as you hit that button, the program will stop and you can go back to editing your code. So it's no big deal. Just remember that you can always do that. Now, in order to avoid this, I should make this a minus again so that everything is correct. So go ahead and play.